High above the poles, the night sky sometimes bursts into color, shimmering greens, purples, and reds that dance like living ribbons. These magical displays are called auroras, and their story begins far from Earth. The aurora has fascinated observers for centuries, sparking wonder and inspiring myths. Ancient Chinese believed auroras were celestial dragons breathing fire across the heavens. The Vikings believed auroras were reflections of the shields and armor of the Valkyries. And some Native American tribes thought they were campfires of the great hunters. Romans named them after Aurora, goddess of the dawn, who raced across the sky to announce the sun. Auroras are most often seen in the polar regions. They are known as the Aurora borealis in the northern hemisphere and the Aurora australis in the southern hemisphere. But what creates this otherworldly glow? It all starts with our sun. The sun constantly emits a stream of charged particles known as the solar wind, which can be harmful to Earth. But fortunately, Earth has a built-in shield, its magnetic field. This invisible force field deflects most of the solar wind, protecting life on our planet. However, at the north and south poles, these magnetic field lines converge, acting like a funnel, guiding some of those charged particles directly into our upper atmosphere. The charged particles from the solar wind move at extremely high speeds, carrying a significant amount of kinetic energy. When these fast-moving solar particles slam into atoms and molecules of gases in Earth's upper atmosphere, like oxygen and nitrogen, they transfer a portion of their kinetic energy to the atmospheric gases. This energy transfer excites the atmospheric atoms, causing their electrons to jump to a higher energy state. This excited state is unstable. To return to their normal, or ground, state, the atmospheric atoms release the excess energy by emitting a photon of light. This is the light we see as the aurora. The colors depend on which gases are hit and how high in the atmosphere it happens. Green, the most common auroral color, is produced by oxygen at lower altitudes, while a rarer red comes from oxygen at higher altitudes. Nitrogen contributes to the purples and blues seen in the display. Together, they paint the sky with one of nature's most stunning light shows. They're most often seen in high-latitude regions like Norway, Canada, Alaska, or Antarctica. But if a powerful solar storm strikes, they can stretch far beyond, dazzling skies where they're rarely seen. By studying the aurora, scientists gain crucial insights into the sun's activity, Earth's magnetic field, and the complex dynamics of space weather, knowledge that helps us protect our satellites and power grids. Born from solar storms and shaped by Earth's magnetic shield, the aurora is more than just beauty. It proves how deeply our Earth is connected to the sun